Okay. Once again, good afternoon, all of you. So, in morning lecture, we have covered the last point of the first topic, that is lumped heat capacity analysis. So, in that, we have discussed about the what is meant by steady state heat conduction, what is meant by steady state. Then we have discussed about the what is meant by unsteady state. After that, we have discussed about the what is meant by non-periodic variation. After that, what is meant by periodic variation. Then we have discussed about the lumped parameter analysis. So in that we have discussed about the temperature is the function of only time. So temperature is the not function of x, y, z coordinates. Okay. So after that we have discussed about the what is meant by Biot number. So we know that what is meant by Biot number. Biot number is the ratio of internal conduction resistance to the surface convection resistance. And what is the formula for Biot number? That is HLC by K. Then we have discussed about the significance of the Biot number. If Biot number is 1, then internal resistance is equal to surface resistance. If Biot number is less than 1, then thermal conduction resistance is less than thermal convection resistance. So this is the significance of that Biot number. After that, we have discussed the equation for the temperature distribution. And what is the final equation we get? That is T minus T infinity divided by Ti minus T infinity is equal to e raised to minus h into a into t divided by rho into v into t. Okay. Then we get the another equation that is in the form of time constant, that is T minus T infinity divided by Ti minus T infinity is equal to e raised to minus t upon T of th, that is time constant. Okay. After that, we have discussed about the that same equation in the form of Biot number and Fourier's number. We get the equation as a t minus t infinity divided by ti minus t infinity is equal to e raised to minus Biot number into Fourier number. After that, we have discussed about the characteristic length. So what is by characteristic length? Characteristic length is nothing but it is the ratio of volume of solid to the surface area of the solid. So we have derived the equations for the different shapes, that is flat plate, cylinder, then sphere, and then cube. So what is the equation for the flat plate? What is the equation for flat plate? So L by 2 is the equation for the flat plate. Then what is the equation for the cylinder? R by 2. Then what is the equation for the sphere? R by 3. And what is the equation for the cube? That is L by 6. Then after that we have discussed about the what is the Fourier number. So what is the Fourier number? It is the ratio of the rate of heat conduction to the rate of thermal energy storage. And what is the equation for the Fourier number? That is alpha into t divided by LC square. So this is the part that we have discussed in the today's morning lecture. After that, we have discussed one problem related to that. Now we have to discuss the second problem. Okay. So all of you write down the second problem. So write down. This is the second problem. Write down a solid copper sphere of 10 centimeter diameter, a solid copper sphere, a solid copper sphere of 10 centimeter diameter, a solid copper sphere of 10 centimeter diameter, in bracket rho is equal to 8954 kg per meter cube. Density is given, density is equal to 8954 kg per meter cube. A solid copper sphere of 10 centimeter diameter, in bracket rho is equal to 8954 kg per meter cube. Then Cp is given, Cp is equal to 383 joule per kg Kelvin. Cp is equal to 383 joule per kg Kelvin, 383 joule per kg Kelvin, and K is equal to K is equal to 386 watt per meter Kelvin. 386 watt per meter Kelvin. Bracket complete. Initially at a uniform temperature. Initially at a uniform temperature. At a uniform temperature, Ti is equal to 250 degrees Celsius. 250 degrees Celsius is suddenly immersed in a well stirred fluid. Ti is equal to 250 degrees Celsius is suddenly immersed in a stirred fluid stirred fluid which is maintained at a uniform temperature, which is maintained at a uniform temperature 50 degrees Celsius, which is maintained at a uniform temperature 50 degrees Celsius. Full stop. The heat transfer coefficient between the sphere and the fluid, the heat transfer coefficient between the sphere and the fluid is H is equal to 200 watt per meter square Kelvin. H is equal to 200 watt per meter square Kelvin. Full stop. Determine the temperature of the copper block. Determine the temperature of the copper block at T is equal to 5 minutes. Determine the temperature of the copper block at T is equal to 5 minutes. At T is equal to 5 minutes after the immersion. T is equal to 5 minutes after the immersion. Okay. So all of you, first of all, we have to read the problem carefully and we have to understood which parameters are given. So a solid copper sphere. So first of all, we have to understood shape is the sphere of 10 centimeter diameter. So diameter is given. So write down given things. Diameter is equal to 10 centimeter. So we have to convert that 10 centimeter into 0.1 meter. Okay. So the diameter of the sphere is given. So D is equal to 0.1 meter. Then density is given 8954 kg per meter cube. Then Cp is given. Write down Cp is equal to 383 joule per kg Kelvin. 383 joule per kg Kelvin. Then K thermal conductivity is given. K is equal to 386 watt per meter Kelvin. 386 watt per meter Kelvin. Initially at a uniform temperature means initial temperature of that copper sphere is given. So Ti is equal to 250 degrees Celsius. So write down Ti is equal to 250 degrees Celsius. 250 degrees Celsius is suddenly immersed in a well stirred fluid which is maintained at a uniform temperature 50 degrees Celsius. Means T infinity is given. Surrounding temperature is given means T infinity is equal to 50 degrees Celsius. T infinity is equal to T infinity is nothing but surrounding temperature and that temperature is given 50 degrees Celsius. The heat transfer coefficient between the sphere and the fluid is so H is given. H is equal to 200 watt per meter square Kelvin. H is equal to 200 watt per meter square Kelvin. Okay. Determine the temperature of the copper block at T is equal to 5 minutes after the emission. म्हणजे 5 मिनिटानंतर त्या कॉपर स्पिअरचं टेम्परेचर किती होणार आहे ते कॅल्क्युलेट करायचं आहे. So T is given, small t is equal to 5 minutes. We have to convert that into second. So T 5 minutes is nothing but 300 seconds. And our aim is to calculate the capital T. After 5 minutes, what is the temperature of that particular copper sphere? समजले का बघा. कॉपर स्पेअरचं इनिशियल टेम्परेचर आहे 250 डिग्री. नाही ते आपण कशामध्ये पुट करणार आहे, तर ते फ्लूड मध्ये फ्लूड करणार आहे. फ्लूडचं टेम्परेचर दिलेलं आहे 50 डिग्री सेल्सिअस. तर 5 मिनिटानंतर त्या कॉपर स्पेअरचं किती टेम्परेचर होणार आहे ते आपल्याला फाइंड आउट करायचं आहे. ओके. So we know the formula for this. By using that formula, we have to find out the value of capital T, temperature after 5 minutes. तो जो काही कॉपर स्पिअर आहे त्याचं 5 मिनिटानंतर किती टेम्परेचर होणार आहे. We have to find out that temperature. Okay. So first of all, we have to calculate the Biot number. So for the calculation of Biot number, there is a need of characteristic length, and we know what is the standard formula for the characteristic length, that is volume upon surface area. So this is the sphere. So what is the standard formula for the sphere? That is r by 3. So r by 3 is nothing but d by 6. So by putting the value of diameter, we get the value of characteristic length of the sphere. Okay, we have to check the value of the Biot number. Biot number is less than 0.1. Then we have to use the lumped parameter analysis. Okay, so first of all, you have to calculate the value of ELC. Characteristic length is nothing but volume upon surface area. For the sphere, what is the volume? 4/3 pi r cube. And what is the surface area? 4 pi r square. So from that we get the equation as a r by 3. In the form of diameter, what is that equation? D by 6. So diameter is given 0.1 divided by 6. We get the value of characteristic length, that is 0.0167 meter. Okay. So by using this characteristic length, we have to calculate the Biot number. We have to calculate the Biot number. Okay. So what is the standard formula for the Biot number? HLC by K. HLC by K. What is the formula for Biot number? HLC by K. Okay. So H is given 200. LC we have calculated 0.0167. And K is given 386. Put the value into this equation and find out the value of Biot number. So from that we get the Biot number as a 8.64 into 10 raised to minus 3. So Biot number is less than 0.1. So therefore we have to use the lumped analysis method. So we know the standard formula for the lumped analysis method and find out the value of capital T, that is temperature after 5 minutes. So what is the standard formula for lumped analysis? That is T minus T infinity divided by Ti minus T infinity is equal to e raised to minus h into as e raised to minus h into as into t divided by rho into v into c. Okay. So volume by area is nothing but characteristic length. So instead of as by v, we have to write down that directly LC value, that is 0.01667 at the denominator. So we have to calculate the value of T. Surrounding temperature is given 50 degrees Celsius. Initial temperature is given 250. So by the putting the values, e raised to minus h, that is 200. Instead of as by v, we have to put the 0.0167 at the denominator. Density is 8954. Specific heat is 383 and time is given 300 seconds. So by putting all this value, we have to calculate the value of capital T. Okay. Do the calculation by yourself. Don't copy answer directly. First of all, calculation by using the calculator. Whether check the answer is correct or wrong. Okay. So all of you put the values into this equation and find out the value of T, capital T. What is the value of capital T? Okay. Do the calculation and find out the value of capital T. Okay. Problem is over. Reply me in the chat box whether the answer is correct or wrong. Put your answer in the chat box. After 5 minutes, what is the temperature of that sphere? Okay. Yes, I have calculated the answer 120.15. What about others? What is the correct answer? Okay. Dhanashri have calculated 119.855. What about others? Put their answer in the chat box whether the answer is correct. 5 मिनिटानंतर ते टेम्परेचर किती होणार आहे 120°C. इनिशियली किती टेम्परेचर होतं 250. सराउंडिंगचं टेम्परेचर आहे 50. 5 मिनिटानंतर त्याचं टेम्परेचर किती होणार आहे 120°C. ओके. समजा तुमचं बाय चान्स कॅल्क्युलेशन करताना आन्सर चुकला आणि समजा 300 आलं, तुम्हाला समजलं पाहिजे की ते आन्सर रॉंग आहे. बिकॉज आन्सर इज इन बिटवीन 250 to 50. Because surrounding temperature is 50°C and initial temperature is 250. So whatever the temperature we got after 5 minutes, that temperature will be less than 250°C. By mistake, if we got the answer 300°C, then you have to understood that answer is wrong. Then you have to check your calculation and find out the correct answer. Okay. So the final temperature after 5 minutes, that is 120°C. Okay. Then write down the next problem. Write down. This is the one question which is asked in the GATE 16 exam, GATE 2016. Okay. Directly formula oriented problem is there. So in the heat transfer, there are some problems in the GATE exam which is related to the direct formula oriented problems are there. So we have to remember all these formulas and calculate the values. Okay. So write down this third problem. A steel ball a steel ball of 10 mm diameter, a steel ball of 10 mm diameter, a steel ball of a steel ball of 10 mm diameter at 1000 Kelvin, a steel ball of 10 mm diameter at 1000 Kelvin is required to be cooled is required to be cooled is required to be cooled to 350 Kelvin is required to be cooled to 350 Kelvin by immersing cooled to 350 Kelvin by immersing it in by immersing it in a water environment by immersing it in a water environment at a water environment a water environment at 300 Kelvin water environment at 300 Kelvin 300 Kelvin. The convective heat transfer coefficient is the convective heat transfer coefficient is the convective heat transfer coefficient is 1000 watt per meter square Kelvin. The convective heat transfer coefficient is 1000 watt per meter square Kelvin. Full stop. Thermal conductivity of steel is thermal conductivity of steel is thermal conductivity of steel is 40 watt per meter Kelvin. Thermal conductivity of steel is 40 watt per meter Kelvin. 40 watt per meter Kelvin. The time constant for the cooling process is the time constant for the cooling process is 16 seconds. The time constant for the cooling process is 16 seconds. 16 seconds. Full stop. The time required to reach the final temperature is the time required to reach the final temperature is the time required to reach the final temperature is okay. So we have to calculate the time. First of all, we have to understood what parameters given in the problem. So first of all, we have to write down the given things. A steel ball of 10 mm diameter. So write down D is equal to 10 mm. So we have to convert that 10 mm into meter. So that is 0.01 meter at 100 Kelvin. At 100 Kelvin. So initial temperature is given. So Ti is equal to 1000 Kelvin. Sorry, temperature is given 1000 Kelvin. Initial temperature is required to be cooled to 350 Kelvin. So that T is given. After some times, what is the temperature? That temperature is given. T is equal to 350 Kelvin. And by immersing it in a water environment at 300 Kelvin. So surrounding temperature is given. So T infinity is equal to 300 Kelvin. Then heat transfer coefficient is given. H is equal to 1000 watt per meter square Kelvin. So write down H is equal to 1000 watt per meter square Kelvin. Okay. Thermal conductivity is given. K is equal to 40 watt per meter Kelvin. Thermal conductivity of steel is given. K is equal to 40 watt per meter Kelvin. Then time constant is given. So what is the notation? TTH. Time constant TTH is given, that is 16 seconds. TTH is equal to 16 seconds. TTH is equal to 16 seconds. And we have to find out the time required to reach the final temperature. म्हणजे जो काही स्टीलचा बॉल आहे त्याचं इनिशियल टेम्परेचर तुम्हाला दिलेलं आहे 1000 केल्विन. सराउंडिंगचं टेम्परेचर आहे, सराउंडिंगला काय असणार आहे? वॉटर आहे. त्या वॉटरचं टेम्परेचर आहे 300 केल्विन. तर त्या बॉलचं टेम्परेचर 1000 पासून 350 व्हायला किती टाइम लागणार आहे? वी हॅव टू फाइंड आउट दॅट टाइम. सो टी इज इक्वल टू क्वेश्चन मार्क. Okay, so we have to use that lumped parameter analysis equation. What is that equation? T minus T infinity divided by Ti minus T infinity is equal to e raised to. So we have to write down the equation in the form of time constant. So what is the equation in the form of time constant? That is e raised to minus T divided by T of Th, that is time constant. Okay, so T is given, Ti is given, T infinity is given, and time constant is also given. So only unknown quantity is small t, that is time. Okay, so put that values into the equation and find out the value of small t, which is the time required to the changing the temperature from 1000 Kelvin to the 350 Kelvin. 1000 पासून 350 पर्यंत टेम्परेचर यायला किती वेळ लागणार आहे? We have to calculate that time. So put that values into the equation and find out the value of small t. Okay, and we have to check the whether answer is the correct or any different answer is there. Put that answer in the chat box. Okay, Dhanush have calculated 42.22 second. Okay, what about others? Only you have to put the values and find out the value of t. So we have to understood what way we have to do the calculation, because in this term there is a exponential term is there. So we have to take the log on the both side and then we have to do the calculation. Then it is easy to calculate the value of t, because at the side, at the right hand side there is a e raised to something. So that something is unknown quantity. We have to find out that value. So we have to take the log on both sides. First of all, we have to calculate the value of this 350 minus 300 divided by 1000 minus 300. Then we have to take the log on the both side. Then log and e will be opposite term, that will be cancelled. So at the right hand side only minus t divided by 16 is there. And from that we get the value of small t, that is 42.22 seconds. Okay, so this is the question which is asked in the GATE 2016 exam. We have to understood for the solving such type of problems, we have to remember the formulas. If we have to remembering the formulas, then it is very easy to solve this type of problems. Okay, so t is equal to 42 seconds. Means after 42 seconds, that 1000, whatever the steel ball having initial temperature is 1000 degrees Celsius. After 42 seconds, that temperature becomes 350 degrees Celsius. Okay, so this is the problems which is related to the transient heat conduction. Okay, so here our first unit is completed, that is conduction. Now we have to start the unit number 2, that is extended surfaces. What is our second unit? Unit number 2, that is extended surfaces. So all of you write down unit number 2, extended surfaces. Okay, so all of you write down first the syllabus of the unit number 2. Unit number 2, write down the next topic. Here we have completed unit number 1. Total 28 lectures we have spent on the unit number 1. So from that we have to understood how many derivations are there, how many problems are there. Okay, total 28 lectures are for the unit number 1. Now we have to starting the unit number 2, that is extended surfaces. So we have to study properly for unit number 1. So it is very easy to understood the another topic number 2. Okay, then topic number 3, 4, 5, 6. First of all, you have to understood basic concepts related to the heat transfer, which is covered in the unit number 1. Okay, so all of you write down the unit number 2, extended surfaces. Unit number 2, extended surfaces. Extended surfaces. Write down the syllabus. Types and applications of fins. Write down the syllabus for unit number 2. Types and applications of fins. Types and applications of fins. Okay, comma, governing equation for governing equation for governing equation for constant cross section area fins. Governing equation for governing equation for constant cross section area fins, governing equation for constant cross section area fins, constant cross section area fins, comma, solution for fins, solution for fins with, solution for fins with convective tip, solution for fins convective tip with convective tip, solution for fins with convective tip, comma, adequately long, adequately long, in bracket with insulated end, adequately long, adequately long, in bracket with insulated end, with insulated end, adequately long, in bracket with insulated end, with insulated end, bracket complete, insulated end, and infinitely long, and infinitely long, infinitely long, and infinitely long, infinitely long, full stop. Next point, fin effectiveness and efficiency, fin effectiveness and efficiency, fin effectiveness and efficiency, effectiveness and efficiency, in bracket numerical treatment, in bracket numerical treatment, numerical treatment, numerical treatment, okay. So what is the title of unit number 2? That is extended surfaces. In this topic we have to cover the different part, that is what are the different types of the extended surfaces, then what are the applications of the fins. Extended surfaces is nothing but fins. Extended surfaces ला काय म्हणणार आहे आपण, fins म्हणणार आहे. So we have to discuss the what are the different types of these extended surfaces and what are the applications of these extended surfaces, that is applications of the fins. Then we have to discuss about the what is the governing equation for the constant cross section area of the fin. We have to discuss governing equation for the constant cross section area of the fin, and in that we have to see the three cases, case number 1, case number 2, and case number 3. In case number 1 we have to discuss about the infinitely long fin is there. Then in the second case we have to discuss about the fin with insulated end, fin with insulated end, and in the case number 3 we have to discuss about the if the at the one end there is a heat transfer because of the convection, means the tip is the convective tip is there, okay. So these are the three cases. For the these three cases we have to derive the derivations, or we have to derive the equations, and by using that equations we have to calculate the different values, okay. So what are the three cases are there, whatever the extended surface is there. So for that extended surface, if this surface is infinitely long is there, that is the case number 1. If that end is insulated, that is the case number 2. And if the heat transfer at the end because of the convection, that is the case number 3. For these three cases we have to derive the derivation and find out the different values by using the problems, okay. And after that we have to discuss the what is the fin effectiveness and what is the efficiency, what is the equations for that, and we have to solve the some problems related to the effectiveness and the efficiency, effectiveness and the efficiency, okay. So this is about the unit number 2, about the syllabus of the extended surfaces. So basically my question is, what is mean by extended surfaces? Can anyone explain me what is mean by extended surfaces, or what is the use of these extended surfaces? Why there is a need to understand the extended surfaces? Okay. So basically we know that one standard equation for the Newton's law of the cooling. So what is the equation of the Newton's law of the cooling? That is Q is equal to H into A into delta T. समजले बघा, कन्व्हेक्शन साठी आपण कुठला लॉ यूज करतो? व्हॉट इज द लॉ रिलेटेड टू द कन्व्हेक्शन? दॅट इज न्यूटन्स लॉ ऑफ द कूलिंग. अँड व्हॉट इज दॅट इक्वेशन? Q is equal to H into A into delta T. Okay, so that H is nothing but convective heat transfer coefficient. Area is nothing but surface area where the heat transfer is takes place. Then temperature difference is nothing but body temperature minus surrounding temperature. So by using that we have calculating the heat transfer rate. Okay, so suppose we have to consider any system. For the design consideration, the temperature difference is fixed value. Suppose whatever the temperature difference, for the design consideration we have to consider that Ti or To minus Ts, that value becomes fixed value. So what are the different ways to improve that heat transfer rate? What is the way to improve the Q? Okay, so heat transfer rate Q is nothing but H into A into temperature difference. So for the design consideration we have to maintaining the constant temperature difference is there. So what way we have to improve the rate of heat transfer? Anyone? कशा प्रकारे आपण heat transfer rate improve करू शकतोय? What is the another way to improve the heat transfer rate? Anyone? कोण सांगते? From this equation we have to understood what way we have to improve the Q. What is the equation of Q? Q is equal to H into A into delta T. But for the design consideration we have to maintaining the same temperature difference or constant temperature difference. So what is the another way to improve the heat transfer rate? Anyone? By increasing what factors we have to improve the rate of heat transfer? Anyone? Unmute yourself and tell me the answer about that. What is the another way to improve the heat transfer rate? Anyone? काय असणार सांगा? From that equation how to improve Q? Q आपल्याला वाढवायचा आहे तर आपल्याला काय करावं लागेल? Which value we have to improve so that heat transfer rate will be increases? Anyone? Temperature difference आपल्याला constant ठेवायचा आहे for the design consideration. So what is the way to improve the rate of heat transfer? So there are two ways to improve the rate of heat transfer. First is to increase the convective heat transfer coefficient, means we have to increase the value of heat transfer coefficient, that is H. And another way to increase the surface area. H आणि A ची व्हॅल्यू जरी इम्प्रूव्ह केली तर हीट ट्रान्सफर रेट इन्क्रीज होणार आहे. कारण टेम्परेचर डिफरन्स जो आहे तो डिझाईन कन्सिडरेशन साठी आपण काय केलेला आहे? सेम ठेवलेला आहे. सो देर आर टू वेज बाय युझिंग दॅट वी हॅव टू improve the rate of heat transfer by increasing the convective heat transfer coefficient and by increasing the surface area. So by using these two way we have to improve the rate of heat transfer. Okay, but increasing H, that is heat transfer coefficient, may require the installation of pump or fan or replacing the existing one with the larger one. आपल्याला heat transfer coefficient जर improve करायचं असेल then there is a need of pump, fan, or we have to replace the existing system with the larger one. So but this approach may or may not be possible or practical. हे आपण अशा प्रकारे heat transfer coefficient वाढवू शकतोय की बाय तुम्ही पंप यूज करू शकताय by using the fan, by replacing the existing one with the another. But this approach may be or may not be possible or practical. काही केस मध्ये आपण हे यूज करू शकतो पण काही केस मध्ये हे प्रॉब्लेमॅटिक असणार आहे. So we have to go for the to increase the area to improve the heat transfer rate. समजले? heat transfer H वाढवायसाठी आपल्याला पंप यूज केला पाहिजे, फॅन यूज केला पाहिजे, पण ही सिस्टीम जी आहे असं करणं जे आहे ते प्रॅक्टिकली शक्य नाही. सो फॉर दॅट व्हॉट इज द अनदर वे टू इम्प्रूव्ह दी रेट ऑफ हीट ट्रान्सफर? बाय इन्क्रीजिंग दी सरफेस एरिया. म्हणजे आपल्याला कुठला वे राहतोय? फक्त एकच वे राहतोय. बाय इम्प्रूव्हिंग दी सरफेस एरिया वी हॅव टू इन्क्रीज दी रेट ऑफ हीट ट्रान्सफर. Okay, so whatever the surfaces are there we have to increase that surface area. So what way we have to increase the surface area? So for the increasing the surface area we have to use the extended surfaces. समजले का बघा. तर कुठल्या वेन आपण रेट ऑफ हीट ट्रान्सफर वाढवू शकतो बाय युझिंग दी improving the heat transfer coefficient, that is H, or by increasing the surface area. But for the increasing the heat transfer coefficient, there is a need of fan, pump, etc. So this is not a practical or possible way. So only one way to improve the heat transfer coefficient or rate of heat transfer, that is to increase the surface area. So what way we have to increase the surface area? For that we have to use the extended surfaces. That is nothing but we have seen that electrical motor. So on that electric motor there are different fins are there. ओके, जर तुम्ही इलेक्ट्रिकल मोटरची जर बॉडी बघितली तर त्याच्यामध्ये जो काही बॉडी असते ती कशी असते, फिन टाइप बॉडी असते. सो व्हॉट इज द मिनिंग ऑफ दिस? व्हॉट एव्हर द हीट विल बी प्रोड्युसेस इनसाइड दॅट मोटर, द मॅक्झिमम हीट डिसिपेटेड इन टू द सराउंडिंग बाय युझिंग दॅट पर्टिक्युलर फिन्स. हीट ट्रान्सफर रेट आपल्याला वाढवायचा आहे म्हणून जी काही इलेक्ट्रिकल मोटर असते त्याच्यावरती काय असते, फिन टाइप स्ट्रक्चर असते. So because of that fin type structure, what will happen? The maximum heat dissipated into the surrounding. Okay. So another example is radiator, automobile radiator. So there are some fins are there. So because of that, whatever the heat which is generated inside the engine, that heat is dissipated into the surrounding. So by using these extended surfaces, we have to dissipate the maximum heat into the surrounding. Okay, by using these extended surfaces or by using these fins, we have to dissipate the maximum heat into the surrounding. Okay, so what are the different applications where we have to use these extended surfaces? There is a economizer of this steam power plant is there, then convector for steam and hot water heating system, then radiator of the automobile, cooling coils, condenser coils. Okay, small capacity compressors are there, transformers of electronic equipments are there, then electrical motor bodies. So these are the applications where we have to use the extended surfaces, and because of that what will happen, maximum heat dissipation into the surrounding is takes place, and because of that life of that particular component will be increases. Okay, मॅक्झिमम हीट आपल्याला काय करायचे, सराउंडिंग मध्ये डिसिपेट करायचे. जर हीट मॅक्झिमम डिसिपेट नाही झाली तर तो कॉम्पोनंट काय होणार आहे, तुमचा ब्रेक होणार आहे. सो फॉर डिसिपेटिंग द मॅक्झिमम हीट इनटू द सराउंडिंग वी हॅव टू increase the surface area by using these extended surfaces. Okay, so this is about the extended surfaces, where what are the applications of the fins. Okay, then what are the types of these extended surfaces? There are different types of fins are there. Uniform state fin is there, then tapered state fin is there, then spline top fin is there. Okay, then fin is there, then annular fin is there. So these are the different types of the fins where we have to use the in the heat transfer. Okay, so write down in the introduction part, we have to write down all of you write down the rate of heat transfer from a surface, the rate of heat transfer from a surface which is at temperature Ts, the rate of heat transfer from a surface which is at temperature Ts to the surrounding medium at To, surrounding medium at To is given by Newton's law of cooling. To is given by Newton's law of cooling. So this is the equation for the convection, that is the Newton's law of the cooling. So write down the formula for the Newton's law of the cooling, that is Q convection is equal to H into surface area into temperature difference. Okay, so Q convection is equal to H into AS into delta T. Okay, so that delta T is nothing but body temperature minus surrounding temperature. Okay, Q convection is nothing but convective heat transfer, H is nothing but heat transfer coefficient, AS is nothing but heat transfer or surface area for the heat transfer. ओके, तर आपल्याला ह्या इक्वेशन वरून समजणार आहे की आपल्याला समजा क्यू वाढवायचा आहे, हीट ट्रान्सफर रेट वाढवायचा आहे, तर डिझाईन कन्सिडरेशन मध्ये आपण टेम्परेचर डिफरन्स सेम ठेवणार आहे. म्हणजे टीएस मायनस टी0 हा जो फॅक्टर असणार आहे तो सेम असणार आहे. सो व्हॉट वे वी हॅव टू इम्प्रूव्ह दी क्यू कन्व्हेक्शन. क्यू कन्व्हेक्शन जर वाढवायचं असेल तर तुम्हाला काय करायला लागेल, एकतर एच वाढवावं लागेल किंवा एएस वाढवावं लागेल. एच म्हणजे काय असणार आहे, हीट ट्रान्सफर कोएफिशियंट असणार आहे. सो व्हॉट इज द वे टू इम्प्रूव्ह दी हीट ट्रान्सफर कोएफिशियंट? बाय युझिंग दी फॅन, पंप, So by using these external devices, we have to improve the H. But so many times it is not possible to use the external devices. Okay, so this is the not possible way to improve the heat transfer rate. So only possible way to improve the heat transfer rate, that is we have to improve the surface area. Okay, so for that we have to use the different fins on that surfaces, so that because of that surface area will be improved and that heat transfer rate is also increases. Okay, so write down this: Q convection, convective heat transfer. H is nothing but heat transfer coefficient, and AS is nothing but heat transfer सरफेस एरिया. ओके, तर ह्या इक्वेशन वरून समजलं असेल की आपल्याला हीट ट्रान्सफर रेट वाढवायचा म्हटल्यानंतर टेम्परेचर डिफरन्स आपण कॉन्स्टंट ठेवणार आहे. एच वाढवायचं असेल तर तुम्हाला फॅन, पंप असे डिव्हाइसेस यूज करायला लागतील. ते प्रॅक्टिकली पॉसिबल नाही. सो ओनली वन वे टू इम्प्रूव्ह दी rate of heat transfer, that is by using increasing the surface area. Okay, write down. So when TS and TO are fixed, when TS and TO are fixed by design consideration, when TS and TO are fixed by design consideration, there are mainly two ways to increase the rate of heat transfer. There are mainly two ways to increase the rate of heat transfer. There are mainly two ways to increase the rate of heat transfer. So what are the two ways to increase the rate of heat transfer? Write down the first way: to increase the convective heat transfer coefficient in bracket H, to increase the convective heat transfer coefficient in bracket H, convective heat transfer coefficient. Second, to increase the surface area, that is AS. अशा प्रकारे रेट ऑफ हीट ट्रान्सफर आपण वाढवू शकतोय बाय इन्क्रीजिंग दी convective heat transfer coefficient or to increase the surface area. To increase the surface area. To increase the surface area. Next line we have to write down dash करून लिहा. Increasing H may require the installation of pump or fan. Increasing H may require the installation of pump or fan, installation of pump or fan, or replacing existing one with, or replacing existing one with a larger one, but this approach may or may not be possible or practical. But this approach may or may not be possible or practical. Full stop. Next line dash करून लिहा. The alternative is to increase the surface area. The alternative is to increase the surface area by attaching to the surface extended. The alternative is to increase the surface area by attaching to the surface extended, called fins, made up of highly conductive material, such as aluminum, fins enhance heat transfer. Aluminum fins enhance heat transfer from a surface by from a surface by from a surface by exposing a larger surface area to convection and radiation. Larger surface area, convection and radiation. Okay. Surface area वाढवल्यामुळे काय होणार आहे? Due to the convection and radiation, heat transfer rate will be increases. So therefore, write on the next line. Whenever the available surface area is found, whenever whenever the available surface area whenever the available surface is found inadequate to transfer the required quantity, whenever the available surface is found inadequate to transfer the required quantity, whenever the available surface is found inadequate to transfer the required quantity of available surface is found inadequate to transfer the required quantity of heat with the available temperature drop and convective heat transfer coefficient available temperature drop and convective heat transfer coefficient extended surfaces or fins are used. Convective heat transfer coefficient extended surface or fins are used. Extended surface or fins are used. Okay. So write down the applications where we have to use these extended surfaces. Write down the applications where we have to use the extended surfaces. Write down first economizer of steam power plant. Economizer for steam power plant. Economizer for steam power plant. Second, convector for steam and hot water heating system. Convector for steam and hot water heating system. Third, radiators of automobiles. Then fourth, air cooled engine cylinder heads. Air cooled engine cylinder heads. Then next application, cooling coils and condenser coils in refrigerator and air conditioners. Cooling coils and condenser coils in refrigerator and air conditioners. Then small capacity compressors. Then electric motor bodies. And last one, transformers of electronic equipments. Transformers of electronic equipments. Transformers and electronic equipments, etc. So these are the applications: economizer of steam power plant, radiator of automobiles, air cooled engine cylinder heads, then cooling and condenser coils in the refrigerator and air conditioner, then electric motor bodies, transformers and electric equipments, etc., where we have to use the extended surfaces so that maximum heat dissipation into the surrounding is takes place. And what are the assumptions for this to solve this, or why use these extended surfaces? So write down these assumptions made in analysis of fins. So now we have to see the derivations on for these fins. So for this derivation or for the analysis of the fins, we have to assuming some assumptions. So what are these assumptions? So write down assumptions made in analysis of fins. What are the assumptions made in analysis of fins? Write down the assumptions. Steady state heat conduction. First assumption in steady state heat conduction. Second, no heat generation within the fin. No heat generation within the fin. No heat generation within the fin. Then uniform heat transfer coefficient over the entire surface. Uniform heat transfer coefficient over the entire surface of fin. Okay. Homogeneous and isotropic fin material. Homogeneous and isotropic fin material. Then negligible contact thermal resistance. Negligible contact thermal resistance. Next, heat conduction, one dimensional. Heat conductional, one dimensional. Heat conduction जी होणार आहे ती one dimensional असणार आहे. And negligible radiation. And negligible radiation. Okay, these are the assumptions for the analysis of the fins. ज्यावेळेला आपण डेरिव्हेशन बघणार आहे त्यावेळेला आपण ही assumptions कन्सिडर करणार आहे. म्हणजे हीट ट्रान्सफर जी असणार आहे ती स्टेडी स्टेट असणार आहे, इंटरनल हीट जनरेशन नसणार आहे, युनिफॉर्म हीट ट्रान्सफर कोएफिशिएंट
मग
असणार
कसं
आहे.
केलं तर तसं कर की.
काय करू?
कसं केलं तू हिथनं डायरेक्ट ह्याच्यात घुसलेलं तसं इझी होईल उलट.
प्रणव,
कळलं का तुला? ते काम कर मग राहू दे ते तिच्यात थोडस अजून ऍड कर हिथनं असं म्हणजे असं 2 लेअर होतील.
मग हे एकच का केलं नाही मी? दोरा जाड पाहिजे म्हणून आहे ना ते.
okay, so we have to stop here. In next lecture we
का
have
काढलं
to
सगळं?
मग काय करू? एक एक ओवत बसूय मी. हसतोय. हसतोयस काय?
काय हे कशाचं काय तू? अरे मी रेज हँड का केलंय?